And we're live. Hey everybody, we're going to just sort of sit tight for another minute or so and just let everyone trickle in.
Good afternoon, Sam.
Good
or
morning,
evening. It's probably evening for you.
Evening for me, yeah. And about midday-ish, something like that for you.
8-ish?
Like that.
Is it really 8?
6.
6
for me.
Oh.
Yeah. I can't tell. It's been dark all day, so.
Yeah, like I was creeping and just looking out your window right there. It looks super dark.
Yeah. Hasn't been the best weather here. But yeah, I wonder where everyone's from. Let's see. $11 a.m. Andreas. Nice. Yeah, we're still trying to figure out what time these webinars are best for, really, because at some point you're going to cut off a continent somewhere. So giving this a try, but yeah, I can appreciate it's quite late for people Eastern Europe and beyond.
Great White North. Nice. It looks like it's all over the place. Nice. The noon,
cool.
Noon here, just turned 12.
Nice. Okay, let's give it another minute or so. Is this the first, Alan? Is this the first team up that Serverless Guru and Momento have done on a webinar or anything before? I think so, right?
Yes.
Yeah.
Yes. I mean, unless you count the podcast that you and I just did like 3 weeks ago.
Yeah, could do, I guess. Yeah, that's cool. Hope we can do a bit more in the future. To be honest, it's pretty cool, pretty exciting. Yeah, I mean, yes, it's always late afternoon for Europe. Otherwise, it's exactly, especially on the West Coast, right? On the Pacific side, it's like 9-10 a.m. there. Okay, I think that's enough small talk. I think we can probably get going. Jonathan, if you can bring up my screen, we'll sort of do a little intro to what we're doing for the next hour, talking serverless and saving cash. So, I need to present my screen. Hold on. That's my bad. Nice. I think I've done 3 of these webinars for Serverless Guru so far. The first one I was on mute at the start and didn't realize, and then the third one I forgot to share my screen. So we can be on Teams for 2 or 3 years, but we're still making these mistakes. Okay, I think that's kind of get started really. So, it's what it says on the tin really. Serverless Guru meets Momento, and 1 hour we're going to be talking about spending less, going serverless. It's possible, we swear. Yeah, there's a lot of talk around the cost implications of serverless and whatnot. So I think what we're hoping in this hour is there's some takeaway points that maybe you haven't quite considered with the architectures and the implementations that you're doing in your day-to-day jobs. Maybe there's one or two things that you could fine tune. Maybe there's like a whole approach to saving costs somewhere that you've never heard of. And Alan and I have saved your company a load of cash. That's what we want you to get from the next hour or so. We're going to break it down into sort of thirds, kind of two halves. So I'm going to start with some very broad cost optimization strategies, sort of some take-home points that maybe you haven't thought about. There's a particular configuration in a service that you're using, for example. We'll talk about some basic architectures and common things that you could probably do as you move from project to project. Then we're going to pass the screen along to Alan. Alan, obviously, Momento at the forefront of serverless caching, so he's definitely the one to do a 20-minute deep dive, more in going a little bit deeper than what I'm doing, actually into some of the caching strategies at the implementation level. And then we're going to be sort of breaking down Swag Hunt at the same time, which I'll leave Alan to explain. And then we'll have a Q&A at the end. If any questions come up on sort of my piece, there'll be a natural pause after about 25 minutes. So we'll answer something from the chat. So if you have questions, don't hold back. Feel free to just let loose in the comments and we'll address them at a natural pause. So, yeah, it's so myself and Alan, but Alan can introduce himself later. Let's start with me. So right now I'm a senior serverless developer. I've been in the serverless space since about 2019. The whole paradigm, I absolutely love it. And now I find myself at Serverless Guru, who I'm obviously presenting this webinar sort of on behalf of, I guess. So who is Serverless Guru, for those of you that don't know? So we provide consultancy, development, support and education in the serverless space. We've got over 75 engineers, architects, AWS heroes, AWS community builders as part of the company. And we have clients big and small, located all around the world. So whatever.
All right. Is it just me?
Hey folks, so it seems like we are having a slight bit of technical difficulty. Hi, background Jonathan here. You guys don't usually see me in the background here. I'm usually creeping. So as we get, hey, Houston, we have a problem here. Sam seemed to have left the orbit of our presentation here. So just giving it a minute, guys. Any opinions on the background here? I have this cheese head, and that was very sad watching that yesterday. If there's anyone who watched football, I'm not sure. I know, Almir, you said that you're watching in Europe where, American football is huge, right? Oh, okay. I think Sam is back, which means I can thankfully leave the screen, guys. Here, let's add him back on.
You're doing great, though, Jonathan.
Oh, well, thank you. All right, guys. Back to the host.
Yeah.
I wasn't here.
No worries. Not too sure what happened there. I came back in for Cheesehead, Jonathan. I'm a big Chicago Bears fan, so I don't appreciate that Cheesehead in the background.
All right, Sam, I'm coming back on for that just now. I'm just okay, yeah. Enjoy, guys.
Brilliant. Not too sure where I got to on describing who Serverless Guru was. Let me just start that again. So because everything just went silent, I looked at my other screen and saw there was an error on the streaming site. So anyway, Serverless Guru, who are we? We're a team of over 75 developers, architects, educators, which obviously specializing in serverless technologies. We've got clients, big and small, located all around the world. And so whatever stage you are on your serverless journey, if you want some help with your architecture, some development help, some education to upskill developers within your team, speak to a guru today. You can get to our websites. You've found the webinar, so you can get through our YouTube. If not, we're pretty high on the SEO, so searching Serverless Guru, you won't struggle to find us. And feel free to reach out there if you like our assistance. So let's continue. So cost optimization strategies. So 25 minutes, I'm going to be going, as I said, relatively high level, some common architectures, and some practices that maybe you can take home and apply yourselves. So a little bit of housekeeping before we start. We've got to bring up a few things. Obviously, reInvent just finished. One of the keynotes, the frugal architect was brought up. It's I think it's 10 laws. You can get to it from the QR code there. It's still live. And we're not going to dig too much into it, Alan and I. We think it's more at kind of the business or the architecture level with some of those like business processes to ensure that you're keeping your cloud costs under control. Saying that, a lot of it does apply to what we're talking about, but we're not going to be talking about any of the laws. Let me just leave it up a little bit longer for those of you who want to grab the QR code, but the frugalarchitect.com should resolve in your browser. Okay. Another little bit of housekeeping, but we are going to refer to this a little bit more maybe, is what the total cost of ownership means. What it means in serverless, what it means in software engineering as a whole. Because obviously some people look at a serverless bill or they look at the price of Lambda, compare it with EC2 and say, well, serverless is expensive. But there's some nuances there, isn't there, as we all know. So we, of course, have those infrastructure costs. If you're running EC2s, you're running them all the time. Whereas with something like Lambda functions, you're being charged on your invocations or whilst your code is running. Aside from that, though, there are other things. There's the maintenance costs with things like servers and databases where you have to do security patches or OS patching, having engineers on call that can hop onto machines, reboot particular applications if something's locking up. Whereas with the serverless paradigm, we're sort of shifting a lot of that to our cloud provider to do some of that maintenance for us. So it does balance the books a little bit there. And then there's also the development cost as well. So it's obviously a bit of a learning curve with serverless, it's fair to say. But once you've got it, it's very easy to churn out microservices, churn out Lambda functions, churn out APIs relatively quickly. So those development costs, you get a very sort of quick feedback loop, and the software development lifecycle process is streamlined a little bit. So you can bear that in mind as well. You can build more applications quicker. Now, I promise that we're going to talk about sort of three architectures today. We're going to use as our sort of our case studies. So let me define them now as well. So let's start with one here, a very typical REST API coming from a web client, going into a API gateway in Amazon that invokes a Lambda function, and let's just say it's using a DynamoDB backend for its data storage. So very, very simple here with a synchronous invocation of Lambda. Now, another architecture. So this is a sort of a streaming architecture. And we could even use the database from the previous slide from here. That DynamoDB could perhaps have a DynamoDB stream enabled. And we could have a Lambda function that's been configured with an event source mapping to receive those events and do a streamed invocation of the Lambda. Maybe that Lambda is doing something that takes a little bit of time. For example, maybe it's sending and receiving a prompt/response from Amazon Bedrock via the API. That can take maybe 20 seconds, so that Lambda could be running for a while. And let's say it's sort of this destination, what it does at the end, let's say it's generating an image in Bedrock and it's throwing it into an S3 bucket and then sending an event into a custom Amazon event bridge, let's just say. So this is a streamed Lambda invocation. So we've had our synchronous invocation, we have our streamed invocation, and this is sort of the one to complete the triplet, which is the asynchronous invocation. So you'll see this a lot in the in event-driven architectures, event-driven designs, where you've got a Lambda function that is either being invoked via an event that's hitting Amazon Event Bridge, or an Amazon SQS queue, where the polling mechanism batches up your messages and invokes your Lambda function with them. And then let's say that it's playing around with S3. Maybe that image that we just generated is in S3. It's not too important. These are the three main architectures: our synchronous API, our sort of asynchronous stream, and an event-driven asynchronous workflow. So let's break down our first example. And I want to look at the different ways that we price these different services. Something about services, we rely a lot on managed services. And they all have their own sort of pricing strategies, as opposed to running everything on a server where you're paying for that hardware. It's harder to understand the cost of your architectures. And that's one of the challenges in serverless that hasn't been solved today. So API gateway, what are you charged on? you're charged on your number of requests, and you're charged on your caching. So at a very high level, how can we reduce costs? We'll make sure you're just caching what sort of needs to be cached, and limit the amount of requests coming into your API gateway. We'll talk more about that in a second. We look at Lambda. So the two ways that your build on Lambda is for the duration that your code has been running, and for the number of sort of individual requests to invoke a Lambda function. Together, that then gives you your Lambda bill. And obviously, configurations can change the rate at which you are charged, and we'll talk more about that soon. And finally, we have DynamoDB, our data storage. So we've got you're obviously paid for the amount of data you store. And then you've also got your read and your write requests. So the amount of reading and writing you're doing to the database will also up your bill. So that's kind of summarize everything that I mentioned there. And there is a recurring theme, which I want to sort of point out at the top. And you basically want to minimize the amount of stuff that your code does. If you want to bring your costs down, you only want to make requests or integrate with a service if you really need to. And so what does that look like in this architecture? Well, for example, if you want to minimize the amount of time you are sending a request to API gateway, so this is the first arrow on the left-hand side, maybe you're doing some client-side caching in your web client. So every single request isn't actually going all the way to the backend. So now we look at our second arrow. How do we limit the amount of times that our Amazon API gateway is invoking our Lambda functions? So there's two ways. You can utilize caching within API gateway, which I'm going to leave Anne to go into a lot more detail in later. But you could also utilize things like your API event schema or event payload validation. So if you're using the right kind of integration with Lambda, you can actually define the schema that your request body should be. And if the request body doesn't meet that JSON schema, it will simply send back a 400 response. And it means you haven't invoked your Lambda function downstream, you haven't paid for that request, you haven't paid for that duration, and you've saved yourself a little bit of money. And then finally, from Lambda to DynamoDB, how do we minimize the amount of time that we actually have to fetch our data or read our data, write our data? But again, probably utilizing some caching, which I will leave to Alan as well. Now looking at the bottom, minimizing the duration of our Lambda function. How do we minimize our Lambda bill? Next slide, I'm going to dig a little bit deeper into that one. So I'm going to sort of park that conversation. And how do we minimize our storage with DynamoDB? So have you thought about expiring items using the TTL attribute, for example? If you're unaware that that exists, you should look into that. It's a way of expiring your stale data, and you don't even have to sort of do anything. It's all configuration driven. So that's a way of ensuring that you're only keeping your unstale data, the data that's useful for your company, in your database and paying for it. Now, let's focus on the Lambda. It's the compute node when it comes to serverless, so it's obviously very, very important. And so I'm going to now talk for a few minutes about Lambda power tuning. So QR code on the right-hand side if you want to check out the documentation and the repo. But for those of you that don't know, Lambda power tuning is an open source tool to help you give you a visualization of what the configuration of your Lambda function should be. So specifically, what your memory allocation is, and therefore your vCPU allocation as well, because they're coupled. The way that it works is it will run your Lambda function, and this is all powered via a state machine that deploys into your AWS account. It will deploy your Lambda function in certain flavors. So each flavor will be running with a different memory allocation. And right from the bottom, 128 meg, all the way up to the maximum that's supported. I'm not sure, it's in the gigabytes. And what it does is invoke your Lambda function, and it's going to present to you a very nice screen like this. And so with this, we can see, I will walk through the graph in a second, that for each of your different memory allocations, you can see how long your Lambda took to invoke and how much that invocation cost. So let's look at this example here. Let's assume that we have our stable product and we just use the default or the minimum 128 meg because it was an MVP and we didn't want to cost a load of money. We're now in production and maybe we need to reduce our cost somehow. And maybe you thought, okay, let's use Lambda Power Tune. Let's see what we can do. So let's focus on the red or the pink line, first of all, with our invocation time. So of course, as you've increased your memory, typically your invocation time goes down. You have more RAM available, you have more CPU cores, so it's quite natural to see a decline. But at a certain point, so in this case here, after 512 meg, we see it levels out. It's telling us as you're giving it more juice, it's not completing its invocation any quicker. So that's an interesting point to note. Now let's look at the blue line. So the blue line is our cost. And we can see there's sort of a slight increase, saying us that our Lambda is costing more, and then it drops down, which doesn't make sense because if we're increasing the memory, we're increasing the amount that we're charged per second of Lambda usage. So why is it going down? Well, that's because our invocation time has also gone down, looking back at the pink line. And remember, you're charged per second, let's say, that your Lambda is running code for. So if you reduce the amount of time your Lambda is running, you may be able to cancel out the increase in your rate of being charged because you've increased the memory. And usually you can get to a sweet spot, which we've circled here, where we've actually reduced our cost compared to 128 meg, and we've actually improved our performance. So you can see how this tool can be very, very useful. And then beyond 512, it's very clear that the price goes up linearly, and we're not getting much of an improvement in our performance. So we've got our flat line and then our gradient going up. So it tells us that any more memory than that isn't really necessary. It's surplus and it's a waste of money. So in this scenario, this Lambda function should be configured with 512 meg. Let's look at a second situation here. Again, let's start with the red line, which is our execution time. So this time it's kind of it's got a consistent gradient that's sort of tending towards 0. So essentially, as you're giving it more juice, as you're giving it a larger memory configuration, the performance naturally improves and we get a smaller invocation time. Now let's look at the blue line, which is the cost. So the cost is relatively similar to start with. We get a little dip around the 1 gigabyte to 1500 meg range, and then it shoots up again. And so what we've circled here being option A is, again, that sweet spot where our cost hasn't really increased, it's actually decreased compared with our original 128. However, our execution times come way down from 35 seconds down to what looks like about 3. So it looks like it's gone down 10-folds, 10 times quicker, and it's actually cheaper. Now, this isn't a one-size-fits-all. And I wanted to bring it up with this section here. So I've circled the orange because typically that's our sweet spot. However, maybe this Lambda function is part of a trading platform where speed is everything, in which case you may actually want option B. So if you look on the right-hand side with the savings, yes, you may end up having to pay a lot more with option B. However, to get a 92% speed improvement as opposed to 91 could be the difference between your platform succeeding and failing. So bearing that in mind as well, yes, you want to get your Lambda bill down, but you also want to make sure that you are you're serving your business. If your Lambda needs to be fast, then it needs to be fast. Okay, so enough on power tuning. I think that summarizes one way in which you can minimize your Lambda costs. Let's look at our second architecture. So we finished our synchronous API gateway, and now let's look at a streaming architecture. So we have a DynamoDB, and let's say that we're using a DynamoDB stream to then invoke a Lambda function. So in terms of the cost here, I know it's very small, but don't worry, you saw it on the previous slides. I'm just showing you here the Lambda costs. So you do pay for the DynamoDB stream. However, it's not really something that you can control, I don't think. So we're going to sort of breeze over that. That's just a cost you have to suck up. But we have this Lambda function. So again, if we can reduce our duration or reduce our requests, then perhaps we can reduce and save a little bit of money. One way that you could do that is by implementing filtering on your DynamoDB stream. So for example, if you wanted to invoke a Lambda function when a particular attribute is added to your items, I don't know what the attribute could be. Let's say that we add a name attribute. Well, our DynamoDB stream will have sort of all of our item mutations, our creations, our updates, our deletes, and you can filter on that first of all. However, maybe we've got other processes that are adding different attributes. Now, if you don't use filtering, this Lambda function is going to run almost every single time an item is mutated. And as part of that Lambda, you put the right logic to figure out whether you should even run the bit of code you need to run. And whilst that bit of code runs, you're incurring costs and your serverless architecture price goes up. So if you utilize filtering on your event source mapping, your Lambda function will only be invoked when your particular filter is met. And you can filter based on particular attributes being inserted, for example. So that's one key here for this particular event source mapping. Now we've got this Amazon Bedrock API call. It can be to anything, a slow API. There's a ton of them. The payment APIs like Stripe. And fortunately, that's something you have to suck up at the moment. You have to wait for that response. However, let's look at the destination. So we said that we could maybe put out an image. Maybe we're generating an image with Bedrock, and we're going to write it to Amazon S3. Well, consider the different storage tiers that Amazon S3 has. So again, it's what I've shown, tiny, so I apologize, but it's not too important. Most of us are aware of the different sort of the standards, the infrequent access, Glacier and whatnot. So choosing the right storage type to ensure that as those images get generated, you are storing them in the most cost-effective way if you need to. If you need to receive these images and pull them again relatively soon, then maybe standard is the defaults, which you may need to use. If not, maybe consider using the infrequent access or the Glacier. We've also got sort of Event Bridge here. There's nothing to really mention about this. You can't say too much in terms of pushing events to Event Bridge. You need those events, unfortunately. But let's now move to our event-driven architecture, which is our third point, which sort of feeds into what we just had. So we have Event Bridge or SQS invoking a Lambda function in an asynchronous manner. Maybe it's talking to an S3 bucket. So what are the ways in which we could potentially reduce this Lambda function invocation? So again, we have the duration and the number of requests. In terms of the duration, kind of hard to reduce it here. I don't think you can do a lot with this event source mapping. However, in terms of the number of requests, one big thing that you can consider doing, the same applies for your DynamoDB streams, I believe, is you're batching up your events. So thinking very much about SQS and how it does that long poll with the batching window. We've all seen that configuration in CloudFormation or in Serverless framework. Maybe we gloss over it and just leave in the defaults. But maybe we need to put a bit of thought into them. Make sure we're doing a batching window that we need. If you can batch all of your events and process them in one Lambda, you could save quite a lot of cost at scale. So consider that. Same applies for the DynamoDB streams as well, Kinesis and whatnot. So I believe, yes, time for a break. So this would be our sort of our natural shift towards Alan. Just going to check whether there's any questions in here that would be related to what we've got right now. So question from Craig on, how can I know if my request or invocation continue to be minimized? Let me just find what you mean by that. How can I know if my requests or invocations can continue to be minimized? Alan, can you chime in on that question at all? Sorry, Craig, I don't quite understand what maybe it was the context of when you sent it is important here.
Yeah, this was when you were talking about caching, I believe, when you had the synchronous API workflow up. This question popped up.
Okay. In which case, maybe we leave this for you to answer, because I think you're going to answer this in your slides, right? And you gave all the different stages of caching.
I will address it, probably not directly. Craigmon, if you want to just kind of async, add a little bit more detail on that question, we can circle back and make sure that we answer it the way that you need it answered.
Perfect. We had another question as well from Craigmon. So Bedrock being new, how reasonable is the pricing? In my experience, obviously, Craigmon, you're on the hackathon webinars. I remember seeing you in the comments. So you're aware that Lorenzo and I built a Santa chatbot app as an example for the hackathon that we're running. That's obviously been powered by Bedrock in the back end. Yeah, we found it to be expensive. Reason being, there's a lot that we need to learn about these services, especially when you're doing sort of like conversations. So when you're doing the conversations, whatever you're using, whether it's LangChain or maybe Bedrock agents, that whole conversation needs to be passed in as sort of input tokens, which drives up the cost as well, which isn't great. I think waiting for the Lambda function, so as part of that Lambda function, sending the prompt and waiting for the response, I think is the bigger risk at cost. And so think about what we mentioned in the webinar about how we sort of decoupled everything, and we don't let sort of like the API that's going all the way back to the client wait for that whole response. But yeah, unfortunately, that's the issue. And I think it's a new technology. I'm sure in 5 years' time, we're going to be laughing at how slow Bedrock and OpenAI are. But yeah, it's the compute that's calling it that we found to be a risk for cost. Alan, do you have anything you want to add to that? Or are you going to go for toying around, as we'll find out with AI?
Well, like with that specifically, I haven't messed around with it yet, but at reInvent step functions, the step function team released a new feature where you can call Bedrock natively directly inside of your state machines. So if you have a standard workflow, you're not going to be charged for that compute time. That's it. Standard state machines are charged for state transitions, which means doesn't matter how long it takes. As long as you can distract your users efficiently or effectively, then great. That's a really big cost saving.
Yeah, that's right. Because we have, for those of you that would be unaware, there's also the express workflows where you'll build based on how long your state machine runs for. Whereas, as Alan said, with the standard one, you'll just build on when your states move from A to B, for example. So that's a good point. Oh, Lorenzo's actually here in the chat. So Bedrock pricing based on the use tokens. Yeah. So the bigger your prompts, the more it costs, and the bigger the response as well. It's also very like no one's really found a use case for caching with these LLMs as well, because it's obviously all generative, so there isn't really much of a use case. So we find that a lot of these systems, they do need to get all the way to the back end every time because there's no data to replicate. It's different every time.
There's nuance to that answer, but we will. That's probably a whole other discussion that we could have. Because there is actually a Momento plugin in LangChain for prompt caching. But I do have a little bit of conversation to talk about when it comes to caching, specifically with Bedrock, when we're talking about the app that I made for reInvent. So let me share my screen real quick. Should be coming up. There we go. Well, I guess it's fine that we can see the browser, but that's okay. Okay, so my name's Alan Helton. I work at Momento as an ecosystem engineer, which is a fancy way of saying I'm a developer advocate. So what I do day in, day out is stuff like this. I get to talk to people. I get to come up with cool use cases. I get to build those cool use cases, and then I go talk about them in various forms, webinars being one of them. I am an AWS serverless hero, which really just means that I contribute to the community a lot. I go and I learn, and then I tell people about what I learn, and AWS liked that I did that, so they named me a serverless hero. Probably most importantly on this list, I am a farmer. I have chickens, turkeys, goats, gardens, kids, a whole lot that keep me busy outside of work, pretty much always doing something. That picture, that is not my sloth. Sloths are a lot of work, so I decided to stick with the goats and the domestic animals. But let's stop talking about me and let's talk a little bit about Momento. If you're unfamiliar with us, like who we are and what we do. So I'll give you the elevator pitch real quick, and then we'll talk about how we can save money with caching specifically. So Momento is really focused on developer experience, making people productive and getting you to your end goal as fast as possible. And how do we do that? We do that serverlessly. And serverless, over the past year or two has really gone through an identity crisis with some of the recent releases that we've seen from AWS. And I'm not going to go into those specifically, but when I say serverless, there are some kind of guiding lights that we have. It's no instances to manage, configuration's really baked in, management's baked in. I really, as a developer and a builder, just want things to work, and I want to leave it to the experts to handle the hard part, so I can handle the business functionality and solve the business problem. And so that's what Momento strives to do, and we do that through a variety of different services. We started off with caching, which is really what I'm going to be focusing on here for the rest of the webinar. But we also have really cool services that are serverless in nature for event messaging with our topics, and also getting into the AI game. We have a vector index as well. So if you're looking for things like RAG pipelines, or if you just want even basic similarity searches, you can absolutely do that in a serverless way. So a lot of fun there. But let's talk about the important part. Let's talk about saving money, and let's talk about how we do that via caching. Now, everybody knows what caching is, but there's actually a lot more to it than what we know. And in the context of saving money, it really should be your best friend when we're talking about building serverless architectures, because of all of the things that Sam has already said, it provides you. It lets you run your Lambda functions for less time. It lets you make fewer downstream calls. It lets you really do a whole number of things. And we're actually going to talk about different types of caching that prevents you from making calls at all. And we'll talk specifically about how that's done. So this is the pattern that everybody knows when we're talking about caching. This is the one that people think, oh, I don't have a use case for caching. They think of this, and this is called read-aside caching. This is where you go and you fetch data from your database and shove it in the cache. So the very next time that you call it, you can pull it out of the cache and prevent a subsequent call to your database. Specifically, what we're looking at is more or less a breakdown of what happens inside of a Lambda function. So this is just a very basic get, fetching data out of the database on a cache miss, meaning it's not in the cache. What we'll do is we'll first look at the cache. It's not there. We're going to go to the database. Then we're going to put it in the cache for next time. Again, which means on a cache hit, I'm just going to the cache and I'm returning immediately. All that downstream processing, every transform that I've already done, I don't have to do. So I'm saving a lot of time in my response, because all the work's already done and I can just return that back to the caller. So when we're talking about cost savings, let's actually look at a specific example. So let's imagine that database call that we're doing is a query, and that query is returning 20 items at about 5 kilobytes each. Now, what that equates to in DynamoDB cost is 40 read capacity units. So if we go and we run that 1 million times, what that's going to end up resulting in is we're going to not have an extra 40 million read capacity units. And we're also going to be saving 97 milliseconds of compute time and transform time times 1 million. So I know this is serverless, and you really have to get up to really considerable amount of scale. You know, your hobby project it's all going to be free. But you start talking about scale and you start talking about millions of requests, billions of requests, these actually start to add up. I think it's always funny when I first started solutions architecture, I was an enterprise architect at a relatively large company. I would have to come up with these totally random numbers to make it actually look like serverless was saving us a lot of money, because it's so inexpensive on its own. So I started doing, this is what would happen if we had 1 million requests a day, 10 million requests a day, just to give tangible numbers to executives to actually believe me that it was this cheap. So we're going to be focusing on 1 million requests today, something that's not completely unreasonable, but still kind of exceeds hobby projects. So read-aside cache, you hit a get endpoint 1 million times, and we'll save, you know, approximately $11 because we cached a call, a very simple call. That's really all you have to do. And this is the one that everybody knows. Now, the next type of caching I want to talk about is write-aside caching. So read-aside caching is really good if you have read-heavy workloads, meaning the data is not changing very often, and you fetch that data a lot. A lot of our workloads that we see are read-heavy. But write-heavy workloads, where your data is constantly changing, you would really want to proactively. They were throwing me off my game here. Thank you. I chose that font specifically because it was festive. When we have write-heavy workloads, we go and we proactively update the cache because you don't want that data to get stale. So in a very simple AWS architecture, what that's going to result in is a DynamoDB stream that triggers a Lambda function, and then we can go and update the cache in there. And I didn't put specific numbers on write-aside caching because it really varies, right? You're going to increase your cache hit rate, which is good, which means you're going to be reducing the number of database calls over, move screen over here in your Lambda function. But pretty much on every write, you're going to be triggering another Lambda function, another DynamoDB stream that you're paying for. So it's a trade-off, as is everything inside of software development. So it depends, is performance your utmost priority, or is it cost savings? If it's cost savings, maybe we just stick with read. But then again, it depends. Are you pulling a lot of data back? Are you pulling a little bit of data back? So good trade-off here. Now I want to talk a little bit about more advanced caching use cases, because those are always the fun ones. They're also the hardest ones to explain. So in order to explain it, we're going to talk about an app that I made. And this is an app that I wrote for reInvent a couple weeks ago to track swag. If you've ever been, you know that's all everybody cares about is swag. You go into the expo, you race to the biggest booths because they usually have the coolest swag, and you grab them, try not to talk to anybody while you're there, and fill up the bags that you're carrying around. So what I did was I tried to bolster that behavior and wrote an app that lets you do that, and it lets you find where the cool swag is. So really all I did was I wrote this app and I said, hey, upload pictures of the swag that you find, say where you got it, and I'll take care of the rest. And, I anticipated, because reInvent's a really big conference, I anticipated there to be a lot of traffic. I designed it in a way to implement caching at pretty much every level from top to bottom. And that's what I want to talk about because it's a really interesting build. So with Swag Hunt, you go to swaghunt.io. It's actually still live if you want to go take a look at it. And you select a photo and you say who gave it to you. Maybe this was swag from Momento. And then you say, where'd you get it? Maybe the booth number. That's what people were doing at reInvent. And that goes and it triggers some behind the scenes workflows. There were some cool AI things that I did, really mostly in step functions. And we're not going to go through the entirety of the details there because we're going to focus on caching. But it ran and it hit OpenAI to do some identification. So if you took a picture of a hat, I passed that picture to OpenAI with vision. And I said, what is this? What swag is this? And I gave it a list of options, and it would return that back to me. And then I would go and save that in DynamoDB. And I would also store that metadata inside of the vector index so I could do similarity searches. And we'll get to that in a minute. But I did a lot of AI processing on these photos to try to minimize the barrier to entry and encourage people to actually use Swag Hunt. So caching. Now that we know what Swag Hunt is and what it did, let's talk about caching. And there were really two main things with Swag Hunt as far as caching is concerned. And it was listing and it was searching. Listing is you log on to swaghunt.io and it lists in popularity order all the swag that was uploaded to the conference. So you could go in and click a little up icon to upvote swag when you thought it was really cool, and that would change the sort order. Subsequently, you could search, and what that search did was use the Momento vector index to do a similarity search. So you can say, I want to see who has socks, and it would return all the socks that were uploaded from reInvent. And you could go and see, just bounce from booth to booth to figure out or to go get the socks if that's really what you were after. Now, both of those are relatively expensive operations because what we're dealing with is AI with the search, but B, we're also dealing with assets. The whole thing was images, and that can get pretty costly when you're talking about serving that to potentially thousands of end users. So let's walk through some of the iterations that I had. So list, this was the most standard, the most basic thing. You log on to Swag Hunt and you get served images. And the very first iteration that I had on list was just pulling the image straight out of S3 directly to end users' phones, which sounds like an okay thing. That's a good iteration. That's a proof of concept. But let's figure out why that's not a production ready practice. When we're talking about 1 million image fetches, the data transfer, assuming that the images are about 150K each, which is about what they were, that would cost about $13.50. There's a free tier with S3, but once you pass that, it's $13.50 for every 1 million requests after. And then a lot of people don't know you actually have to pay for the amount of times that you fetch things out of S3. It's not just data transfer. So 40 cents ish on a get request. And it was slow. I built this prior to that One Zone Express S3 release. So it would take, 15 seconds on a bad load for an image, which is just not acceptable today. So I iterated a little bit. I got it working and decided, you know what? Performance really needs to be of topmost priority, because I can build the greatest app in the world, but if it's not fast, people aren't going to use it. They're going to abandon it. So I did what anybody would do, and I put CloudFront in front of it. And this is a type of caching. This is CloudFront is a CDN, content delivery network, that lives regionally close to where your end users are calling. So what would end up happening is an image would get pulled out of S3. It would get replicated across all these edge locations inside of CloudFront and then get served from there. And the benefits of using CloudFront are that the data transfer is a lot cheaper. It has a much more generous free tier every month. It's 1 terabyte versus 100 gig. And the data transfer is actually a little bit cheaper as well. It was like $13.50 for 1 million requests at 150K each for S3, and it's $12.75. So a little bit cheaper, but at a massive scale, that adds up pretty quick. Get requests are actually more expensive through CloudFront, so you benefit greatly if your images are larger or if your assets are a little bit bigger, because your data transfer costs will go down, even though your access request costs go up. And I found that the speed still wasn't fast enough, because on cache misses, meaning I am loading an image for the first time, it still has to go to S3. And then it comes back to CloudFront and it caches in its CDN, however that works. And then it sends it back down to the end user machine. So it was faster, but I was still seeing like 10-second load times on new images. And I didn't like that. I didn't think that was fast enough, even on single cache misses. So back to the drawing board again, because yes, I improved the cost. Yes, I improved the speed, but I wanted to do better on both. So the last one that I did is I actually went and did a novel approach that was a proof of concept for Momento, as much as it was for me learning. And instead of using a content delivery network, I just used Momento in the browser to load the assets. Now, what would happen is in the back end, when I was processing all of the images, when they would come in, when they were uploaded from users, is I'd identify the swag, and then I would go ahead and shove it into the cache and set the time to live in Momento for 5 days, which was the length of the conference. And I said, for the entire length of the conference, keep this in the cache, keep this hot and available. So whenever anybody needs it, use it. And with Momento, you can access the services from backend services. You can also access the services from the front end, from the browser. So they were sharing the same cache, my backend processes, my step function workflows, and the Next.js app that I had that was serving all these assets. So somebody would log in, and I would issue a token that says, yes, you can load data out of my cache. And it was super, super fast. Like, even if I didn't work for Momento, I would be saying that was a big win, because I went from 10 seconds-ish on a cache miss to no cache misses, because part of the processing was adding it to the cache. I was doing a write-aside cache, and it taking milliseconds, 10 milliseconds to load an asset. I still fell back on the CDN in case something happened, like maybe I hit a throughput limit, but it was significantly faster going and using Momento from there. So I see a question that says, did the max TTL get extended on Momento? You can always ask. The 24-hour TTL limit is a soft limit. So all you have to do is ask and we'll increase it. The max that we have on there is 30 days. So justify the use case. For me, the use case was I have a conference that extends for 5 days and I need things there for 5 days. So they updated that for me. Okay, so that was the 3 iterations of list. I went from serving S3 down directly, then I went to a CDN with CloudFront, and then ultimately I landed on going Momento and pulling that data directly from the browser. And it was much faster. The data transfer costs, they're higher than CloudFront, higher than S3. It's 50 cents a gig, but I was caching the assets inside of the browser session, so I didn't have to load them over and over again. Yet another form of caching. So let's talk about search. Let's talk about the second use case. And this one was actually, it was a lot more involved than list, because list is just pull some records out of DynamoDB and return them back with pointers. This one was a lot more, because you search for hat, and the very first thing that you have to do when you're searching a vector index is turn the search query into a vector itself. You can't do plain text searches inside of a vector database. You have to do vector searches inside of a vector database. So the first thing I would do inside this Lambda function is a simple read aside check. Did somebody search for this recently? Did somebody search for a hat in the last minute? If they did, go ahead and kick it back out right now. I'm going to skip all the heavy lifting because somebody searched for it recently, and I'll just return that. And I cached it for a minute because data was constantly changing. I had images uploading and I didn't want to return stale data. So cache that for a minute. If nobody has searched that in the past minute, I checked to see, did somebody search for that query? Did somebody search for a hat before? And if they had, I would use my cached embedding and prevent myself from going and calling Bedrock. So let me talk about the miss real quick. If I was searching for a brand new search term, if I was searching for bright yellow hat, I'd get a cache miss, and I would go to Bedrock. I'd make a call inside of this Lambda function to Bedrock to make a vector embedding of bright yellow hat. And then I would cache that embedding. An embedding is just an array of numbers that has the semantic meaning of your search query. And then I'd go and search Momento vector index. And this is very much, it's like a double read aside pattern inside of this Lambda function, because I'm caching the results and then I'm caching a static embedding. You can generate an embedding of the same search query a million times, and it's going to be the same a million times. So somebody did a search, I would cache that for 5 days, because that's not going to change the shape of the embedding. We just reuse that over and over. Now let's bring back these cost modeling and how much time and everything that this costs. Now remember, we're talking about serverless numbers, so this I'm not talking about saving thousands and thousands of dollars. We're only talking about 1 million requests. So I have cached 3 million input tokens to the Titan embeddings model inside of Bedrock, saving me $2.40 every million requests. And then I've also saved myself a considerable amount of Lambda execution time, about 270 milliseconds every search on a cache hit. So those add up, of course, when you get to millions and millions of executions, which is a lot of fun. Okay, I see I'm running low on time, so we're going to keep going real quick. Another thing that I did, another type of caching that you can do is HTTP caching, which means if I don't even have to I don't even have to hit the API at all from my Next.js app. When I return the response from the Lambda function, I've added a header called cache control with a max age of 30 seconds, public, which means I can serve this out to anybody else making this call, and then say revalidate after 30 seconds, which means makes the call after 30 seconds. So what that means is my app, my front end app, isn't going to make the same identical call from anywhere for 30 seconds. It's going to pull that out of the CDN, the Amplify CDN, which is CloudFront, but it's not going to make the call and hit my my API, which is really nice. And then, of course, down here, I'm still serving the assets out of Momento via the browser. So when we're talking about cost savings, when you're doing HTTP caching, it's all of it. It's all the individual request API gateway. It's all the invocations of Lambda. It's all the downstream resources, because the answers or the responses are just being replayed down on the individual client. So a lot of cost savings from a front end strategy there. So let's talk a little bit about where we've cached. You can see here's a very high level of everything that we talked about. We have the list and we have the searching. And we've talked about a bunch of different types of caching. We have the database caching from our list. We have our API caching, where we're not going to be calling Bedrock to encode or create embeddings out of search queries. We have our HTTP caching, meaning we're not making calls at all from our front end app. We have the browser caching that we did. So we fetched our assets out of Momento from the browser and then cached those in the browser so we can see if they've already been loaded before. And then the last type of caching that we had was asset caching via a CDN, via CloudFront. So we can get those images to live a little bit closer and affect our data transfer. Now, really, all this is to say, that's a lot of caching. And because this was a read-heavy workload, that was good. But every single type of caching that we did here saves us money, like directly. And this is why you cache. But caching can also bite you if you don't do it right. If you have write-heavy workloads and you're not updating the cache when data changes, you're going to serve stale data, and you don't want that. So be smart and do a little bit of research on how often your data changes, how often you need to cache stuff and revalidate and all that. So it's not a silver bullet, but you do have a lot of options when it comes to caching. And really, any one of these, I could have implemented any single one of these on its own and started saving money on that build. So since we're getting pretty close to time, just gonna jump straight to here. Swag Hunt, it was a moderate success. It wasn't as used as I would have liked, given the amount of time that I spent building and iterating on it. But we had 83 pieces of swag uploaded. A curious thing for me, I instrumented all the metrics in here. So I was trying to figure out, what are people searching for? What do they want to see? Turns out hats. Hats is what people wanted to see the most of anything. Hats, stickers, and then shirts. It wasn't socks. It wasn't toys. It wasn't PlayStation 5. It was hats. And I was just so intrigued on that one. The most viewed, the Momento hat, which I thought was super nice. That was really cool. Really cool to see. And then some other things there. But the big thing to note here is that even though there was only 83 things uploaded, it's still rendered more than 85,000 images on individual phones and desktops. So the caching from end to end it helped. And to answer David's question, what was the final bill on Swag Hunt? It was like $12. And that included the OpenAI bill and all of that. And that included all the testing that I did. So serverless, very, very inexpensive, especially when you do the caching at every layer. So that is all that I have. Here's one more festive slide for you in case you wanted to see the source code for Swag Hunt and see how I implemented caching at all these different layers. Check out Momento. I saw a couple other questions about Momento. How does it compare to Elasticache? Well, it's our favorite topic to talk about. Elasticache, it's not true serverless in the sense that I was talking about serverless at the beginning. You have required VPCs. You have minimum spend that you're required to to spend on Elasticache, and you don't with Momento. You're not provisioning instances. You don't have to worry about scale up, scale down. It's just available and works just via API calls. Yeah. So that's probably, Craig Mount, we can talk about that one offline. We can go into some detail on Momento versus Elasticache. Happy to talk about that. But yeah, there's a flow of questions coming in. Did I use Momento leaderboards in Swag Hunt? No, I did not. I just added some metrics inside of DynamoDB. I didn't even use CloudWatch for that. I just published an event whenever something happens and just tracked it via DynamoDB records. All right.
Perfect. Hey guys, coming on again. I think Sam's still having a little bit of technical difficulties. I think he was on just a minute ago, but he can't actually hear what's going on. He just sees, our pretty faces talking about, Elasticache and Momento right now. But if anyone has any additional questions as they flow in, I'll make sure to put them on screen. Let Alan take some time to answer any questions. If there's anything for Sam as well, I could always get that, give it to them, and read out the answer aloud. We'll do a little game of telephone here, but hopefully you won't need to hear from me too much. So sorry, Alan, cut you off there.
No problem. No worries.
Let's see. Let's go through a little bit of some questions. Is there anything that we missed? Did you get to Daniel's question, Alan? I think he asked something about 150 kilobytes per image for...
Yeah. I glossed over a lot of what I did in that backend. That backend was actually doing a hefty amount of stuff. So I did resize. I converted all the images that came into WebP format, which is a browser optimized image type, and scaled it down considerably. I did some A/B testing and figured out what the smallest size was that still looked okay. But yeah, yes, all of it was in the mind of cost savings. The iPhone images that came in were massive, like 4.5 meg or something like that. So got to scale those down because I was intending on serving that to, potentially hundreds or thousands of people.
Awesome. I don't know if this is a question. I think Sam may have answered this in the comments, but I just want to get your perspective on it. It's from David. What is the E2E latency? This is why I usually don't jump on these things. E2E latency with DynamoDB streams to Lambda. Hey, I know DDB.
Yeah. So the end-to-end latency, it really depends on how you have your event source mapping. There are two ways to trigger a Lambda function off of a DynamoDB stream, and that's a batching window. So up to X number of changes have occurred. So let's say you're trying to do batches of 10. And then there's also a amount of time. So if there's any changes, let's say you want to do batches of 10 and you had your one push in the database, one database change. There we go. And you said, either give me 10 or batch things up in 30 seconds, do a 30-second max wait. So if fewer than 10 results have come in that 30 seconds, it will trigger after 30 seconds. So David, I know everybody's favorite answer is it depends. A lot of times, especially when you're talking about caching, what you want to do in that scenario is do batches of one. So you're processing everything in sequential order, because when you're doing the batching, depending on how you process the items in that batch, I tend to do things in parallel, but that doesn't really work when you're doing write-aside caching. So 1-to-1, which is only a few milliseconds of time.
Awesome. I definitely want to get something that when someone says like it depends on one of these webinars, we get like confetti or something. I don't know if that'd be even possible, but if anyone can get on that, I think that would be that'd be a big player in the technical webinar scene. Anytime you say it depends and like confetti or like the word of the day shows up, kind of like Pee Wee Herman. So that's my favorite thing is it depends. But coming up to maybe our last question, unless anyone else has any in the comments from Craig Mott. He's wanting to know, what would you have done differently looking back for Swag Hunt if you could have done anything differently, if you didn't go over that already?
Yeah, I probably would have started with using Momento more in the front end. I had to optimize some code from things I've hacked together in projects in the past, and I was really dreading doing it right because this was intended to be a production application. And I just dragged my feet and really ran out. I had to work a lot more during the week of Thanksgiving than I wanted to because I was figuring things out because I dragged my feet and didn't implement it just from the get-go. Overall, though, as far as like architecturally, I'm actually very happy with the way that things turned out. I'm happy at the iterations that I made and the way that it ended up. I probably subsequently also would have used CloudWatch metrics instead of tracking everything inside of DynamoDB, so I can get time-based metrics instead of just overall. So I could see who was uploading what when kind of thing if I was just doing CloudWatch metrics.
That's awesome. Do you think this is something you might take? No, this is coming from Jonathan now. This is something that you might take to other conferences and events, something that you might roll out any other time you, maybe like a serverless days or something else, Alan? Or is
100%. 100%. Yeah. I actually built it with that in mind. I parameterized the conference name in the source code, so I can just change a environment variable in the deployment pipeline, and it no longer says reInvent. It says Serverless Days Tennessee or wherever.
That's awesome. All right, guys. 2024 Serverless Days Tennessee. The Swag Hunt is coming to you guys. But that's awesome. That's looking ahead as well. So I'm looking forward to using Swag Hunt anytime that I go to any conferences if it's available. I definitely want to try it out. I unfortunately couldn't make it at reInvent this year. I'm sure people can relate, but I definitely wanted to try out Swag Hunt if I can get the chance. So if you guys get the chance and see Alan around in any conferences, please bug him about Swag Hunt if you don't already are using it currently or anything like that. And he may give you a hat or whatever's the most popular thing at the conference. No guarantees from me. Again, I'm speaking not on behalf of Alan, but the things that you possibly could get. But awesome. If there's no other questions, guys, I think we've hit time. I'll bring Sam back onto screen. I don't know if you can hear or say anything, Sam, but just having you here, is
yeah, I think I'm okay now. Yeah, got the English weather. Yeah, nothing else to really add. Thanks, Alan, for that second half. That was really interesting. I learned a ton as well.
Yep, great times, a lot of fun.
Yep, this was great, guys. And, as always, this is my first outro for the webinar. So as always, guys, as I always do, thank you for joining. If you did miss any parts of it or want to rewatch anything, it will be available on YouTube. Feel free to hit up Alan and Sam on social media. I know Sam doesn't use Twitter as much, but you can still find him at that handle on LinkedIn. It's still Serverless Sam _.
Yeah, that's right, yeah.
Not the Serverless Sam, the squirrel one that Alan has on his desk, but the Serverless _Sam. Same name, different things, but and make sure to follow Alan Helton Dev. I made the mistake of not including the dev on Twitter, so make sure not to forget that. Give a follow to Momento, our friends over on the other side of this webinar. And as always, thank you, and come again. Come back, guys. Come back to our webinars. All right, next time we have one, show up again. All right, please. Okay, I shouldn't be the one doing this outro, guys. I'll hop off, and please give it some kind of wrap up, and I'll end it on the back end.
I don't even want to follow that, Jonathan. I just kind of want to turn it off right now. Let everyone focus on your face and that beautiful outro.
All right, sounds good, guys. See you guys, everybody, later. We're ending the stream. Thank you guys for joining, and see you on the next one. Bye, guys.